Okay, in this video, we're going to cover composition of functions. So this is another way to do operations on two functions that is outside of the four generic algebraic operations. So this isn't adding, it's not subtracting, it's not dividing, it's not multiplying. It's the taking of two, or could be more functions, but two for us, and we're going to be combining them in a special way. And that's going to be putting one inside the other one. So we see here we have two functions. We have the g function with a variable of x, and we have the f function with another variable of x. It doesn't matter what the variables are, but now the function themselves is as if this is the name of the function g, this is the actual function right here. Okay, so the g function is 2x minus 7. Same thing over here, the f function is x minus 2. And it's going to be important to know which function is which, and also where the variables are located in each function. So we can do this in two ways using the same two functions. First, we have this. Now it looks like it says fog of x. This is supposed to be a little bit smaller of a circle. But the way you say this statement right here is f of g of x. So what this is telling me is that it wants us to take the g function, the g of x function, so right here, 2x minus 7, and substitute it into the x in the f of x function. So they want us to take the g function, 2x minus 7, and substitute that into the x in the f of x function. And then we can reverse that by doing this one, which again, you pronounce this g of f of x. And this one wants us to take the f function and substitute it into the x of the g of x function. So this would be the other way around. You've taken the x minus 2, which is the f function, and substituting that into the x of the g function. And you can see my examples right here where I actually do these two things out. So here we have f of g of x. So we're taking the g function and putting it inside of the f function. So 2x minus 7 will go where x is over here, so it replaces it. So instead of saying x minus 2, we have 2x minus 7 minus 2. And from there, we simplify. So 2x remains 2x. We have negative 7 minus 2 is negative 9. And so that's what f of g of x would equal. G of f of x, same thing. This time we're taking the f function, substituting to the g function. So we have x minus 2 replacing the x in the g of x function. So here, instead of seeing 2x minus 7, we see 2 times x minus 2, the f function, then minus 7. And then once you have that, you simplify. So we distribute first. 2 times x is 2x. 2 times negative 2 is negative 4. Minus 7 gets carried down. And then we have 2x minus 4 minus 7 equals 2x minus 11. And that's what the g of f of x function is. So that's all there is to it. It's a lot of substitution in. There are some examples we can go over that I'll show you guys right now. And you actually have to do these two or practice these two. So we have this example where we want to find f of g of x and g of x. Don't worry about this if they exist part. So we're not going to worry about that, any of these problems. So you're going to be doing that here. So remember that f of g of x means taking the g function and substitute into the x for the f function, and g of f of x is taking the f function and putting it into the g function. So f function to the g function. So that's one example. So you can pause the video and do that now, then upload your work after. The next problem we're going to do, and this is probably where it gets a little more complicated, but not super hard. Probably, so I'll give you the hint here. So we have the f function, boom, which is f of x equals x plus 4. And then we have the g function, which is x squared plus 3x minus 10. So these two things are we're substituting in, the red and the blue. So f of g of x is simple enough. We're going to take the g function and put it where the x is in the f function. So all you see here in blue will replace this x right here in the f of x function. And just add 4 and you're done. Now, where it's more complicated is when we do this one, where we take the f and put it inside the g function, so g of f of x, because the g function actually has two x's in it. So when this says take f and substitute it into the x we're in the g function, we have to do that in every single x. So this x plus 4 would be substituted in for this x, and then this x plus 4 would also be substituted in for this x, and then you simplify. One common mistake is that people, when they try to square x plus 4, they don't FOIL the two binomials. They just kind of square each thing. Don't do that. Make sure you do x plus 4 times x plus 4. So yeah, your problems to upload are gonna be, I'll go back up here. You're gonna have to upload this combination, so f of g of x and g of f of x for this problem. And there's two functions, and then upload your work and answers for this combination, f of g of x and g of f of x for this one. And again, don't worry about this if they exist part. So do those two problems, upload your work when you're done. Thanks.